Alright, so chapter 21 is about trash. So, I don't know, questions to think about. How much trash do you guys think you generate every week? And do you think your household could realistically send nothing to the landfill for a month if it tried? No? Under any kind of incentive? Like, let's say that there was an incentive. What kind of incentive would your household need to do that? A little bit of money you would do it, but otherwise totally unrealistic, right? Okay. How much are we talking here? Like 10 cents a can. Okay, so if you get 10 cents a can, you would suddenly send nothing to the landfill? Is that what you're saying? Hi, Anna. Uh huh. Okay. But what about all the other stuff that you can't send to the recycling? Is there stuff? Is everything recyclable? What has to go to the landfill, I guess? You can type in the chat or just say it out loud. Oops, sorry. Food packaging. I agree. Agreement. Yeah. Especially now with the closures and everything, everyone's bringing a lot of packaging home for either takeout, wrapped food. Yeah, food packaging. Reuse it. For what? Okay. But what if you keep getting takeout and you keep getting new containers every time? Okay, use them a little bit more. All right. So I guess again, this is about trash. I want to give a few brief announcements before we begin. Briefly go over chapter 20, which was kind of last week, and then chapter 21 notes. I wrote somewhat brief just because it's not technically material that the AP says it's going to cover, even though the AP gives review sessions on this material, which is really confusing to me, and I'm not really sure what they mean by that. That's so it's better just to go over it anyway, and it's good to talk about trash. Announcements wise, this is mostly for everyone listening on the recording later. I just put in an extra participation category. Everyone got 5 out of 5. That way, if you this most recent time didn't participate enough or something, hopefully that evens it out. Let me know if you have questions about that. Some people have asked me if they can do current events still. Yes, I guess if you want to do a current events, and it would impact your grade in some way, feel free to send me an email. We can set up a time, and then you can give your current event to me and anyone else who wants to join via Zoom, or via Google Meets, like I do. Likewise, there have been questions about term projects, probably not from any seniors, but if you have been working on a project, and I'm not sure how grading will work this term, but if you are working on one and want to give it to me, I will still accept them. I'm guessing that term 3 and 4 will be smushed together. I don't really know. We'll update. And finally, I let you guys know some AP updates about what the exam's going to be like. If you have questions about that, you can ask now, you can ask later. Hi everyone who just joined too. Any questions about logistics stuff? Out of curiosity? No. Alright. Feel free to jump in now or at the end. Looking forward, next week is April break, but APs still have work. The work for our class, Mr. Gay suggested that we look at chapter 22, which is just kind of a bringing together of all chapters. It's about urbanization. It's not new content, but it'll bring stuff together. It's practice. Then we have 2 more weeks before the AP, so then FRQ practice. I'll give you guys a list of the laws and treaties in case you want them. And reviewing select topics, I'll send out a form to see what you want to review. And then the week after that looks basically the same, more FRQ practice, since it's just 2 FRQs and we know what they're about. And then right after that, we have the AP. So good luck in these next few weeks. Okay, chapter 20, you guys were supposed to look at last week. If you didn't get a chance, in one slide, basically the key points from it were that there are like a Great Pacific garbage patch, a lot of plastic floating around the ocean. There's actually 2 of them. They're huge, as you can see from the picture. They went on a little bottled water is kind of evil. The companies doing that are all pretty bad. we usually like to give more nuance in this class, but, bottled water is pretty bad. Just drink out of the tap. It's usually safe, especially in Boston. Eutrophication was a theme. Please be able to explain how eutrophication happens. Oil spills are bad. We also talked about that before. There are other ways. Quality of life with respect to water is improving. Many countries no longer need to worry so much about having access to clean water, though it can be still far away. It's improving, and inventions like the life straw allow people to drink directly from, quote, dirty water and filter it just right there, then and there. Alfie, I'm going to mute you for a sec just because of the static, okay? You can unmute when you want to talk. Yeah. So, also there were some, just like we have the Clean Air Act, we also have the Clean Water Act and a Water Quality Act. For those of us who just joined, feel free to jump in anytime with questions verbally or type them into the chat. Your faces, your voices, and your chat will not be part of the recording. One thing I couldn't fit in on this slide is the idea of sewage treatment. So dirty water is all considered, dirty water and sewage all gets processed in a certain way. You guys probably have heard of Deer Island in Massachusetts. That's where we process all our sewage and dirty water. So how that works is basically all the dirty water from your household, whether that comes from the shower or the washing machine or the toilet, all kind of goes to the septic tank, usually nearby, and then they all get distributed to the local treatment center. What happens at the treatment center? What kinds of things can we clean, and how do we clean them up? Well, there are basically 3 steps in it, and I know this picture is a little bit messy, but the first section is called the primary filtration. So in primary, that's a physical filter. They literally have a screen that gets some of the sludge kind of stuff, and they allow it to settle over time. The particles settle down. You don't need to know the name of every chamber or anything like that, but the big particles basically settle out of the liquid. You physically filter it, nothing chemical there. Then the second step is that you just give the bacteria, these bacteria which like to eat poop, and other kind of sewage, I guess, the bacteria in this activated sludge in the middle, plus oxygen, allow it to purify the water. And then you kill the bacteria with chlorine. And that's it. The primary and secondary stages, that's how we treat sewage. And I don't know what your thoughts on that are, whether that seems clean enough or you're surprised that this is all that happens. But really, this is kind of what nature does too. We've talked about how forests or wetlands will purify water. They also have this kind of primary stage where roots or rocks and just slowing down water will allow particles to settle out. And then plants will take up the nitrates, or bacteria will eat up the toxic material. And then after that treatment, it's all sent away to the river, lake, or ocean. So a question was how much water is recovered in this sewage process. By recovered, if you mean goes to the ocean or lake or river, basically all of the water goes out into the ocean once it's processed. The more interesting question maybe is what happens to this sludge. You can see at the bottom of this diagram, there's a ton of sludge that's made. And this is usually, so what is that? That's poop and nitrates and stuff. That also can go to either a landfill or an ocean, or the kind of used as fertilizer for croplands. And again, that if that sounds disgusting to you, let's remember that in the mid-1900s, the sewage system, even at that point, not every sewage system went to a treatment plant. It used to be that sewage just went into the rivers, without any treatment at all. So at least this is kind of concentrating what a river does over many, many, many miles into a quick process within a couple days. And at least it's kind of filtered out and processed a bit. And also, just because all the water from your household is going to these places, it's not it's mostly poop or something. 99% of that's probably just water from your washing machine, the shower, the sink, etc. So it's actually quite dilute to begin with. It's not as gross as you might imagine. I think I have a slide just outlining those words here, but I'm going to skip through it if I can. There's a little bit of a lag between my presenting screen and this screen. Okay, great. So chapter 21 is our final chapter of new material. Congratulations, you've made it. And it's about solid and hazardous waste. So let's get to it. The core case study, I think it differs by the book. One of them talks about the cradle to grave or cradle to cradle paradigm, and one of them talks about e-waste. I was going to talk about the e-waste because we've talked about cradle to grave before. There's a question about whether sewage processing is something that's being advanced, or if it's currently like kind of good enough, or is there an alternative people use? Right now, the choices you have are basically like between treating it or not treating it. There is also like a tertiary step in the primary, secondary. Some places require additional, let's say like UV treatment or something of the water, using special chemicals to treat it. But most places by law, or in the US, it's only required you do primary and secondary treatment, and a lot of loopholes exist so that places actually get around even doing that much. I don't know of how. I feel like right now the focus for maybe government is to make sure everyone implements primary and secondary, as opposed to like find a new way to treat it, because the alternative is just dumping it straight into the river, which people already do, because rivers are natural filtration systems. All right, so e-waste, we've talked about it a little bit. E-waste is waste that is electronic waste, that's what it's short for. And it's a huge problem that's growing. Just like agriculture was a problem because it's getting worse, e-waste is also a problem that's clearly getting worse as we use more and more electronics. Just think to yourself about how many electronic devices you have, how many of those you will probably throw away in the next 5 years even. Whether you've been getting more electronic devices over time or fewer, it's definitely a growing problem. And, a lot of it ends up just getting thrown away because people aren't good about recycling them. They end up in landfills or in incinerators. And that does not happen in the US. Usually we ship it off to another country. And that's really a huge waste. So the composition of these things is, of course, those precious metals that we talked about. We've talked about conflict minerals, gold, tantalum, tungsten. So they're valuable minerals in there. There are a bunch of plastics that could be reused. So high quality plastics. We'll talk about how there are different types of plastics. But it's also extremely toxic. So when we ship them off to other countries want them because they can reclaim those plastics or those valuable metals. They need it for their economy. But they're also subjecting the workers there to very bad conditions. So when you burn these plastics to get the valuable metal out, you don't want to breathe in toxic fumes. Like, you don't want to breathe in the smell of burning plastic. It's not good for people. There's toxins involved, and so it becomes kind of a human rights issue as well. As I said, we mostly ship it to other places, so 70% of our e-waste ends up in China. And of course, the conditions for work already are worse there. There aren't as strict of laws as to what workers the conditions that workers have to work in. And of course, there are also child workers. So the US produced 7 million tons, basically, of e-waste, 42 pounds a person in a year. So 42 pounds of electronics, and you're like, I don't have 42 pounds of computer. Sure, but like if your family throws away like one washer or something, or one large electronic device, that can kind of affect the average. And of course, companies, it all averages out per capita. And people are bad at recycling it. Most of it, more than 50%, ends up in the trash can. And even though it's a small amount of the total trash we produce, so it's only like 2% of the volume in our landfills, it accounts for most of the heavy metals. 2/3 of the heavy metals. Heavy metals here just means like all the transition metals on the periodic table, things that kind of aren't probably good for you. Like lead would count as a heavy metal, mercury would count as a heavy metal. And All of this, of course, is fed by our kind of consumerist mindsets. The fact that we plan for cradle to grave. These electronics are not designed for reusing their parts. Planned obsolescence, where manufacturers literally plan for a device to only last a couple of years before you need to replace it, instead of designing it for how you can keep using it longer. Whether it's an update to the software that makes your iPhone slow or anything like that, kind of planned obsolescence. Questions about e-waste? All right, so the 3 big ideas for this chapter are about solid waste in general, the thing you've heard before, reduce, reuse, recycle, and how we address hazardous waste. So, what is solid waste? So solid waste comes from 2 different places, or we have 2 large categories of it. One is industrial solid waste, so that's produced by industries, things like farms, like mines. And then there's what we call municipal solid waste, which is often abbreviated MSW. And that is the typical trash that we generate. Trash, but also the recycling and everything else that you throw away. So based on what we've learned so far in this class, and again, this is the last of the new material, so what kind of estimate can you make? What % of waste do you think is industrial? And you can type it in the chat or say it out loud. What % is industrial, let's say? 75 industrial, 30 industrial. These are very different numbers. They're like the complement of each other. It's okay. All right. 2 guesses for a few people. 25 is industrial. All right. So, you might remember from chapter 14, I think, non-renewable minerals. Do you remember those mountains of overburden when you mine a material up? When mountaintops were removed and giant piles of waste. It turns out because of mining in particular, mining alone is more than half. So industrial, there are estimates, and this number is put into question because it's very hard to count waste. But there seemed to be no better number I could find where everyone seemed to quote the same number of around 97% of waste is industrial. And I agree. I'm very surprised by this, but everyone seemed to only have 1 paper to quote on it. That said, that does not mean that we are not the ones responsible. It doesn't mean we're not the ones responsible because the reason that this mining is happening is because of the kind of consumerist mindset that we have. I'm not sure if I'm frozen or if other... Okay, seems okay now. But again, just because it's industrial doesn't mean that we're not at fault. The kind of big picture takeaway I want you to have is that we throw out a ton of useful things. You can always type in the chat if I am frozen, by the way. I'm not sure what the connectivity is like. But please let me know if I freeze. But we throw away lots and lots of useful things. What goes into the landfill usually does not have to go to the landfill. We can do other things with it. And yet we still throw it away. So as far as your life goes, what kinds of things do you throw away most? Which waste that you generate is worse for the environment? I heard food packaging earlier was a big one. But maybe life before coronavirus, before the closure, what was your biggest source of trash? If you had to carry your trash around with you, what would that trash bag look like? Again, say it out loud or type, or just think to yourself. Cans, lots of cans. And bottles, wrappers, food packaging. So bottles, of course, we could use a metal water bottle instead, but that's fine. Still plastic food packaging. Food packaging is a lot of it. All right, so I guess we'll talk about recycling a bit too. So it's interesting that you all say food packaging, but maybe not food. Maybe you guys are all great about finishing your food, but food waste is actually a huge portion of the waste that we generate as well. So think about all the schools and all the school lunches, maybe even, as a small set of the food that gets thrown away. in the US every day. You will all soon be going to college. Can you imagine moving out of your college dorm room? Just the amount of trash that is generated on move-out date, which was made worse this year because of the coronavirus and everyone leaving. It's just a huge mound of trash, and it's usually a bunch of usable stuff that people bought for 1 year and then had to throw away because they couldn't take it home on a plane with them. So these will just be two that'll be relevant to your daily lives, maybe, or you'll see it soon. You'll see it soon. And, it's part of, again, because we're buying so many things. I don't know how many of you guys have newer iPhones or newer phones in general. Where these phones end up is in places like, I don't know if you've heard of APES Ch at this point, either at a Human Rights Day at some point, or if you just Google like most toxic place, sometimes this comes up as like an e-waste dump site in Ghana. Yes, current events have been done on this before. Across many classes, APES Ch is a place in Ghana where we just dump a lot of e-waste, and people have to burn it to harvest those metals for their livelihoods. So that iPhone turns directly into someone else's shorter lifespan, but also their livelihood, because it's a resource for them. Again, we throw away things that are valuable to other countries. The US in particular, as usual, US #1, etc., we are great at producing trash per capita. And maybe the number of trash bags in front of this household for a family, I think, of 4 in San Diego does not look too bad to you. That's because it's our normal, right? This is over the course of a year. We produce a lot of trash. We do. And again, it's just kind of a mindset. Yeah, it's trash. Go to the North End, it's gross, apparently. But there's a lot of trash produced, and most waste, as you guys probably know, breaks down extraordinarily slowly, or just never. At least we've had some good things have happened there where we don't use like styrofoam as much, but most trash still is just going to stay there longer than you will be alive. It's just going to exist. And so what kinds of things do we do with it? How do we get rid of trash in the US? Well, you know some of the answers, I'm sure. Apparently there's trash in the street in places, but we're still pretty good about it in the US overall. What happens to trash? Just say the obvious answers even. Landfills. Landfills are definitely one thing that happens to trash. It's kind of the last step, though. Landfills are where it goes when we don't have anything else to do with it. Okay, you could litter it and it goes into the ocean. Drains directly. You can burn it, it's true. So some people for the energy unit were like, let's collect all of the trash in the US and burn that to generate energy for Massachusetts. You can recycle them at a can center. Yep. What else can happen? Compost, I agree. I think that was most of the ones I wanted to say. That's good enough. So we have trash generated at 2 steps. Trash is generated in the processing and manufacturing of goods, that second blue square, I guess. And then it's also generated when we use it. So pre-consumer, there's trash made. Post-consumer, there's trash made. We can recycle it. We can compost it. Hazardous waste has to be dealt with separately. Or in the remaining stuff, we can either burn it for energy or throw it away. And then even when you burn it, there's ashes made, and that has to be thrown away. So this is kind of what happens to trash at a very broad scale. Right now I want to talk about the very right-hand side of this diagram, the remaining mixed waste, incinerating it, or landfills. So this diagram should come as no surprise to you all. This is kind of how we can get energy out of trash. Remember, at the top right here, steam, turbine, generator, electricity. This should be a very familiar story from chapter 15 and 16. Anytime you can get water moving to turn a turbine, you will get electricity. So they boil the water by burning trash, and then they move the ash away to a landfill, but the water will turn a turbine to generate electricity, and that's fine. Of course, this option does generate a good amount of pollution. When you burn plastics, as I told you earlier, it was hazardous. So it makes a lot of air pollution, which can be bad for the people who have to live near these kinds of plants. It also is a problem because if you're buying trash, you're like creating a market for it and therefore encouraging waste production. There are some countries that get most of their energy from this kind of process, and then they actually need to buy trash from other countries. They like run out of their own trash, which kind of sounds good because you don't have trash, but then it's also bad because other countries are like, yeah, let's make more trash to sell it, or at least there's no incentive to reduce the amount of trash they produce in the first place. One of these trade-off pages, again, it's good to burn it because now it just becomes ash, less of it has to go to a landfill, and it makes energy. But it's expensive and hazardous. The other thing that we do, of course, is put it into a landfill. This is kind of a diagram of a landfill, lots of words, that's alright. But basically the idea here is that around the compacted solid waste, so you have to compact it so it takes up less space, there's like a bunch of lining. These are called sanitary landfills. It's not just like an open pit somewhere. That's not what we do in most developed countries now. We line this area with like clay, and we have monitoring wells to make sure that the water from the trash, called leachate, doesn't get out. Basically, it's like a sealed kind of landfill area. How many of you, or has anyone heard that like landfill space is going to like run out or like anything like that? Like there are too many landfills, we won't have places to put our trash. Is that a sentiment that people have heard of before? If not, that's totally fine and maybe makes sense, but your parents kind of maybe have heard of the sentiment. That was one of the pushes for like, we need to generate less trash, we need to recycle more because landfill space will run out. That is not really a problem anymore, but there is a video that I've linked in the weekly outline kind of documenting some of those sentiments in the 1900s. There's a comment of Millennium Park. Do you want to explain that a little bit further? Is Millennium Park in Boston? A landfill? I don't actually know where it is. Okay, it's in Boston, but it is a landfill. Thank you. Near Home Depot, for all of you listening. So again, a landfill, it's fine because it's pretty cheap. You just dump it there. You can pour tons of waste in there. There's lots of space for it. But of course, it's still not great to live around because it might, like, it leaks. It can contaminate your groundwater. You get a bunch of extra noise and traffic from all the garbage trucks dumping things there. And also, when you have a bunch of rotting stuff, it releases greenhouse gas. There are technologies in place where you can capture that greenhouse gas and then burn it, but it's just a bunch of decomposing stuff. It's going to release greenhouse gases, just like any other vegetation kind of left to rot. Okay. Questions about solid waste, landfills, or burning it, incinerating. Okay. So the options basically when it comes to solid waste, once it's already there, aren't the best. So you probably have heard of reduce, reuse, recycle in elementary school at this point. But has anyone heard of the 4 R's? Is that a thing that you do? The 4 R's? Yes, I'm seeing some yeses. All right, anyway. So let's say you go to college and you're required to be on a meal plan, because you generally are. And in the dining hall, they use disposable containers for every single meal. This is like not even the stretch of the imagination. They do this at Brown, for instance, in some of their dining halls. There's, a compost, trash bin, recycling bin. What should you do to be most sustainable? Either out loud or into the chat. Hoard them. So Alfie will take them and reuse them. Hoard them and you can use them for other things. They are pretty durable. Ask the college to get reusable ones, like petition them to do that. That change happened while I was at MIT. They switched from disposable takeouts to reusable takeouts. Definitely implementable. Other ideas? You can definitely ask the college to change. It would take a while, but we'll see. All right. Yeah, I mean, it's a hard problem. I know that like a couple of my friends literally bring their own reusable, like they bring a bowl there and ask them to use that bowl instead at the dining hall instead of the disposable ones, which is kind of an interesting way to just take action yourself without waiting as well. But then there are people who don't even bother using the compost recycling bins either, because either they don't know how to use them or they use them incorrectly and everything goes to the trash anyway. So even with all these measures in place, people are still pretty bad at sorting their trash or thinking of solutions to fix it. Because I bet if you asked most students at, say, Brown, not to personally attack that school or anything, but since I know that they have this system in place, I bet most of them would say they care about the environment or they know that it's bad to generate trash. But actually doing something about it is kind of difficult. So how do we manage municipal solid waste and reduce it? Well, management, the difference here is just what do we do to reduce harm on the environment, but not the amount of it itself. On the other hand, reduction of waste is maybe what some people were saying with reusing. I don't think recycling is actually waste reduction, but your book says it is. I guess it's reducing the amount that goes to a landfill by recycling or composting, but even that I think is not so much of a reduction as it is managing it. So kind of pointing to this disconnect between what we know we should do and what we actually do. On the left is what we should do, right? We should reduce, reuse, recycle, then burn it if we can, and then bury it. What we actually do is we bury it. Most of it gets buried, 2/3 or so. We're kind of better there because then we recycle a ton too. We recycle like 25%, a quarter. Then we burn it, and then we reuse a little bit, and then we haven't really reduced at all. So everyone knows reduce, reuse, recycle, and then we still don't do it. So I don't know, that's just something to think about for this chapter. So how do we reduce? This is where the 4 R's comes into place. So what are they? Of course, recycling. There's 2 different ways you can recycle. There's primary recycling. Sorry, my slides are not syncing. Okay, primary recycling is where it's like a closed loop. Like I'm a water bottle company and I collect my water bottles and make more water bottles from those water bottles. That's kind of not losing any resources, but that very rarely happens. Most of the time it's secondary recycling, where I take a bunch of water bottles, melt them down, and make something different, or make new products out of them. I guess using it to make other things. And then you can also reuse. So this is in order of, it'd be better to reuse, to use it over and over. Like someone said, hoard the takeout containers and use them a couple times more, maybe half your waste use that way. You could also, of course, reduce, like use less of it. What is the 4th R of these R's? What is the thing that's better to do than all of these? Yeah, it is to just refuse. So repeating is more like reusing, but refuse means don't use it at all. Like, just say no. There's kind of a big difference in mentality where you go from, I'm going to use this less, to I'm just not going to use it at all. It's kind of like the difference between, like, I'll eat less meat sometimes versus, like, I just won't eat meat at all. It kind of requires a little bit more commitment to just be like, I'll bring my own bowl. Like, I'll just never use it. And then, of course, we can also reduce by composting, which is where we turn waste just naturally with decomposers into kind of soil again. And this takes a few months, usually, if not longer. And you've probably all seen those like compostable bags, compostable packaging at this point, right? Compostable plastics, biodegradable plastics. Sometimes they're labeled as biodegradable, but the composting company won't actually accept that anyway because it takes too long to degrade still. So maybe a company will say, yeah, we use compostable packaging. They send it to a facility that degrades them, but the facility uses, let's say, 30-day cycles to, like, you have a batch, it takes 30 days to decompose, then they take it out. But the plastic bag maybe takes 90 days to decompose. And then the facility won't actually accept those bags because it takes too long. They don't have the time to filter them out and give them 3 cycles. So that just goes to the landfill anyway, or gets burned anyway. A lot of the time, that actually happens to both of our recycling and our composting. A lot of the times we feel pretty good just taking the step to separate these, but after that, at a, I guess, industrial level or higher level, it doesn't meet the end that we think it should meet. So yeah, this is kind of sad news for a lot of, I know VLS does a great job of collecting recycling, for instance, but not all things are actually recyclable. First of all, not all plastic is even recyclable. So you may know this already, but there are those triangles with the numbers in them. Which of these numbers, 1 through 7, are like actually recyclable? There's some pictures of things that are made commonly out of these plastics. Which of these numbers actually are recyclable, like will be used to make other things? I see a vote for 1. I see a vote for 2. All right. So yeah, I'm telling you right now, not all of it's gonna happen. Okay, so I guess when you have these numbers on them, they're just classifying the types of plastic. And there are a lot of types of plastics out there in use. Very commonly, no one will dispute, numbers 1 and 2 are recyclable. 1 and 2, plastic bottles will be used to make more plastic bottles. PET, I forget what that stands for, but HDP, high density polyethylene or something. These 2 types of plastics are easy to reuse. They're kind of, remember in the energy unit we talked about like having high net energy? It was like profitable to do it. Companies in general will think it's fairly profitable to melt these down and make new things, 1 and 2. 3, 4, 5, 6, and 7, actually, all of the other ones, depending on the place and depending on the country, but more often than not, tend to be not that recyclable. So maybe for 6, some people were looking at those and thinking of biodegradable forks or things like that, but generally 1 and 2 get recycled, like actually recycled, like a company will use them to make other things, and then the rest do not. Some cities will just not bother collecting the others, and others will collect it all but then sort it at the recycling facility and send 3 through 7 to burn anyway. And then of the people who do collect it, we used to send a lot of the plastics, even 1 and 2, type 1 and 2, to China, where they would actually use those materials to make new things. But very recently, in I think 2018 or 2019, China decided not to buy more trash from the US. Like no more, either no more or a big reduction in how much trash they bought from the US. And then a lot of other countries in Asia actually followed suit. So recently, actually, and I'm not sure this has been resolved yet. If anyone knows differently, please let me know. But the U.S. has found that they can't export their recycling to other countries, and not many or no companies in the U.S. want to deal with this. So even cities which are really great at recycling, like Portland, Oregon, a lot of their recycling even gets sent to the landfill or burned as of like a couple years ago or this year. So recycling sounds good in theory, and in practice is not going well right now. I think that's an area where people could be doing better. There's also, caveats where a lot of the things that people throw in recycling can't be recycled because they've been touched with food or need to be washed more and things like that. So it's just kind of a problem. What you can do, slides, like don't use it. And paper recycling also exists. So kind of the reason that recycling are theoretically good is because like paper production is terrible for the environment. It's a huge waste of energy. Like in terms of just what consumes energy, like paper production is the 5th largest. Of course, number 1 might be like transportation, which is much, much, much higher. They use a ton of water, the virtual water footprint, and also pollution is generated. So in comparison, producing recycled paper is just much more efficient. It sounds great on paper. So like uses less energy, uses less water, and it produces less air pollution. It sounds like a win-win for everyone. Unfortunately, because energy is so subsidized in the U.S. and elsewhere, it's not like a huge profit change for the companies that make paper, I guess. And it's because the supply chains are already in place. It's easier for them to buy like just from the trees than to collect the recycling and pay for the recycling and sort the recycling and make this paper, which is why recycled paper is still even not that common, even though people have known about the technology for so long. So kind of as a summary of that, recycling is good because it reduces the impact on the environment, in theory. Like, it should, because you don't have to go, remove another mountaintop or deforest another region. However, it's too expensive to be profitable, so it's not subsidized, so people don't do it. There are companies like the people who own landfills and incinerators who might be against it. And it's also just inconvenient, as in like people have to make the right choices. You have to know what goes in recycling, what goes in compost, and those regulations vary from place to place. Sorry, that last bullet is that it still encourages production of trash. Like at the end of the day, you're not changing your mindset to make less trash in the first place. You're still making trash and just sorting it and hoping that the right thing happens to it. So far, I think that sounded kind of depressing, but there have been improvements with respect to trash management. What kinds of improvements can you think of that have happened in your lifetimes that you've noticed? You can type. Hazardous waste disposal, we're going to get there in a bit. Boston got the big blue recycling bins. Schools recycling in general. I agree, BLS does a great job of that. And maybe the things that I'll say later are going to remind you of things that have actually changed or that you didn't realize changed. They're just so commonplace now. But some things include like the fact that we pay for our shopping bags now, right? Like, you don't just use plastic bags all the time. That's great. Like, we used to use, I think, 3,000 bags a second or something in the US. 3,000 plastic bags, which is a ton. And now people are much better about reusing bags. In a lot of cities, there's actually a pay-as-you-throw system. Plastic straws were worth it. I'm not sure what you mean by that, but pay-as-you-throw bans on styrofoam. The fact that we have single-stream recycling, which is like makes it easier for the person. You just throw it all away in the same place. And reuse in general going up. So with regard to plastic straws, like reusable straws are now a thing, kind of, but reusable bags are certainly a thing. And generally reusable like food containers, it's happening a little bit more. Pay as you throw, I don't believe Boston has, but here in California where I am, you can choose the size of trash can you want, like in your household, to put onto the street once a week. And if you choose a smaller size trash bin, you pay less per month than if you had a bigger size trash can. So you have an incentive, monetary incentive, to produce less trash. Like the price for the compost bin and the recycling bin and the trash bin are all different. And the trash bin is the most expensive, and a bigger trash can is even more expensive. That's like a pretty simple way to implement an improvement, like citywide. You'll notice that a lot of these things are monetary, so like the fee per bag and pay as you throw. Though styrofoam was actually just banned entirely. Can you guys remember the last time you used a styrofoam thing from a takeout place? I feel like it might have been when I started college. I don't know. But styrofoam is one of those bad things because it takes basically forever to break down. It won't break down. Though it, of course, still exists in some places. But people actually took action on that, which is great. Okay, so final big idea is addressing hazardous waste. So how do we deal with hazardous waste? What is it? We've kind of talked about this in chapter 17, I believe. But Let's recall that hazardous and toxic waste are bad because they not only threaten the health of the environment, but also human health. What do I mean by hazardous waste? We've talked about things like organic compounds, these persistent organic pollutants, or POPs, like DDT. There's toxic heavy metals, the transition metals again, lead, mercury, those kinds of things, as well as radioactive waste. All of these things are considered hazardous. We've touched upon all of them as well. How do we actually deal with it? Like when you use copper in the chem lab, what happens to it? You're not supposed to pour it down the drain, and that's because it needs to go to a special treatment facility. What can we actually do about this? It's a kind of a similar theme as before. You produce less of it in the first place. So whether that's designing your electronics more friendlily, so you could recover those toxic wastes and recycle them or reuse them. But if you can't do that, you can make them less hazardous. So sometimes we just let it sit on its own, like for radioactive waste, we just wait. Sometimes you can burn it, because burning is a chemical reaction, so it changes the composition of the thing, so it's no longer toxic. Like you could burn plastics and make carbon dioxide out of them. That's the thing you could do. You could also treat them with other chemical reactions or biologically. And of course, you could also just dilute them and hope that it doesn't have a big effect at a small dosage. After that, though, if you can't convert it, you're going to have to store it forever. And that's what we do with the radioactive waste. So radioactive treatment plants kind of last for a very, very long time. You can inject them underground. That's a thing we do. Or we can just put them in, like, basically extra security sanitary landfills, surface impoundments, where you keep it at the surface, but have double linings and such underground. But you can actually treat them naturally. So again, learning from nature, you don't need to read all of this, but basically a bunch of plants can actually take up the pollutants for you. They can absorb even radioactive compounds, and the plant will still sometimes survive, hopefully survive, and then when the plant dies, it will just become part of the soil at like a more natural pace. They can, of course, take up nitrates, but also break down some toxins. They can absorb CO2, for instance, which is classified as a pollutant, things like that. So again, I said there are deep wells, which you can see have the trade-off site. Again, we're worried mostly about leaking and the pollution involved, as well as surface impoundments. Both of them are pretty cheap, but of course the pollution and the leaking are problems both times. Okay. We're near the end now, but I just wanted to remind you that Love Canal happened. That was in New York, where we had the toxic waste site, and a bunch of mothers, took the people hostage and basically had this grassroots movement to change something. And from that, we got CERCLA, which is a law about that provides money in the U.S. to make these Superfund sites. Superfund sites are places that have been contaminated in the United States and need basically toxic remediation. Have I already asked you guys how many Superfund sites exist? I don't remember if I did, or if that was my chem class. All right, how many do we think in the U.S.? 24. 50. I have a helpful picture of the ones in Massachusetts as part of it. All right, 24, 50, 70, 1,000, same person guessing, but that's fine. So it turns out under CERCLA, we already have 40,000 Superfund sites. And you can look at a nice list of them. Some of them are colored green, as in we've dealt with them, and others less so. The money, sometimes, it just takes a very long time to do toxic remediation. Oh, hello. But yeah, Love Canal kind of was the thing that gave people that showed politicians that people cared enough that it gave us the funding to deal with these types of sites. Internationally, there are some regulations on hazardous waste, but not enough. The one that you might have heard of or would want to know about is the Basel Convention, and this is another one of those stories where it's a great idea in theory, and in practice, the US fails to ratify it. So basically, what it does is it bans transfer of hazardous waste, not including radioactive materials, but all other hazardous waste, from industrialized countries to the less developed countries. So basically it says it's illegal to dump all your e-waste in Ghana. But even though many countries ratified it, almost 180 countries ratified it. The US, once again, sets a great example by not doing so. And it's, at this point, considered one of the global treaties on this. It's quite international, though the US still has not, to my knowledge, ratified it. Okay. Questions? Okay. So I just want to end with the idea of really the goal here is a low waste or even a no waste society. And cities have dealt with this in many ways. Next week, when we bring everything together in urbanization, we'll look at kind of some of the things that cities are doing to become greener. But some cities, if you click on that link for the APA, will say that, near net zero waste, or zero waste is a philosophy, and it's not actually a number that we should measure, which I think is ridiculous. Whereas other cities are saying that means we send nothing to the landfill. But a lot of cities are kind of committing to a zero waste goal. I think San Francisco is doing quite well and had an 80% reduction in the amount they sent to landfills and incinerators, but will not meet their 2020 goal, or have not met it. They are doing quite well overall, though. So for all of you who said in the beginning, I don't think it's possible that my household will ever make no waste, I kind of thought that too, and then I came home and I saw that we had different sized trash bins, and we actually were generating 1 bag of landfill trash a week, and I was very surprised at the change that's happened in my house just from pretty small kind of nudge level things that the government has done. And then your book has some key principles about how everything is connected in biogeochemical cycles. There's no real way. You're not throwing it away. It's going to stay there for a very long time. The producers and the polluters and the people who maybe make the trash should pay. And mimicking nature by recycling and composting are kind of the things to strive for.